make some logical connections in all of your work. If I gave you that, what would it be? 3. If I gave you that, what would it be? 10. So the square root must be 3/10. What? I don't get it. But you do. Because if that is the square root of 9/100ths, that means 3/10 times 3/10 would equal 9/100ths. Does it? 3 times 3 is 9. Damn it! 3 times 3 is 9. 10 times 10 is 100. Logic. Don't need to be shown it because you can figure it out, because you people can apply logic to a situation. This one. Now, 225 has a square root, but 48 doesn't, does it? So we better make an estimate. Isn't that awfully close to 225 over 49, which would be 15 over 7? Which, of course, would be 2 and 1/15, right? So pretty close to 2 would be a very good guess. This one. What? 0.25. You can look at that in how many ways? What else could you write that as? 25 over 100. Oh, that's easy. Square root of 25 over 100 is 5 over 10, which is what? 0.5. You could also look at that as 1/4. Square root of 1/4 is 1/2, also 0.5. Lots of ways you can look at it, all ways that you already know without me having to show it to you and without you having to use a calculator, because you are understanding of how numbers work. 1/25, same thing. What is it? 1/5. 0? 0, because 0 times 0 is 0. So what's the square root of 0? 0. 45 doesn't have one, does it? It is what? 6. And that is how many steps past 6? 9 steps past 6. And what's the next one? 13 steps. 9/13 is pretty darn close to what? 9/12, right? 6 and 9/12, which is 6.75, or 3/4. Now, some of you will have gotten out your calculator and done 9 divided by 13. I'm aware that you could have done that. Why would you not do that? Well, because if you were going to do that anyway, why wouldn't you just square root 45? The whole point of this is so you have an idea of what your final answer will be. Obviously, this is negative 6 3/4. 121 is 11. And this one, a lot of people say this one is not rational. So they start estimating it. But of course, 5 over 20 is 1/4, isn't it? And the square root of 1/4 is 1/2. So be careful on ones like that. That is almost 9, isn't it? Approximately square root of 9, which equals 3. That's a little less than 9, so my guess would be a little less than 3. Right? Or you could have done 4, square root of 4, which is 2, and you've gone 4 steps beyond 4 out of 5, which would be 2.8. Okay? Okay. This page I wanted you to do with a calculator because there's some stuff that goes on this page that will help you with the concepts that we are dealing with here that are easily seen once we get out a calculator. Okay? So this first one, rational or irrational? Irrational. This one? So it's just irrational, right? Because 1,728 doesn't have a square root, does it? Okay. Now this one, when you punch that in your calculator, you got what? 30. Now, look at the radicand, 27,000. Look at the answer, 30. And look at the index, 3. Can you see any relationships between 27, 1,000, because 27,000s, 30, and a cube root? Thomas.
There's 3 zeros in the cube root.
So this could be written as 27 times 1,000, couldn't it? What is the cubed root of 27? 3. You've made a list of that. What is the cubed root of 1,000? 10. What is 3 times 10? 30. Does everybody see that? So what does that mean we are allowed to do with these radicands if they are big and ugly? We can break them down into smaller things that with which we can deal. Does everybody understand? Great. Okay. Keep that in your head. What about this guy? Irrational or rational? What is it? 15. What about this guy? It's rational. What is it? 270. Because, of course, that is 729 times 100. The square root of 729 is 27. The square root of 100 is 10. 27 times 10 is 270. Yeah? Now, knowing what you know now, this looks like it should be rational, doesn't it? But is it? No, because that is 100 times 1,000. Now 100 has a square root, that's 10. Does 1,000? Well, it sure does, Mr. Myers, because 1,000, that's 10, 100 times 10. 100 has a square root, it's 10. So 10, 10, oh. It's not 2 factors, is it? It's 3 factors. Picking up what I'm putting down? All right. What about the cubed root of 1,728? What is it? 12. 529? What is it? 23. Cube root of 1,000, you already know from your list. 10. What about this guy? Really? Rational. Of course it's rational. Because it's 14 over 15. What about this guy? Irrational. What about this guy? 4. What about this guy? 0.5. Why? That is 125 over 1,000, correct? What is the cubed root of 125? 5. What is the cubed root of 1,000? 10. 5 over 10 is 1/2, which is 0.5. Now, what's the other way you could look at that? The cubed root of 125 equals 5, right? But you need those decimals. 0.5 times 0.5 times 0.5 gives me 125 with 1, 2, 3 decimal places. 1, 2, 3 decimal places. What about this guy? 5 over 3. Square root of 125 is 5. Square root of 27 is 3. What about this guy? Irrational. Now, that takes us... Oh, not quite. I probably forgot to assign this to you, didn't I? I did forget? Great, do those 2 questions now. Go. We'll call that your warm-up for today. All right, you ready? Excellent. If the surface area of a cube has a side length of 15, then one face is 15 squared, yes? How many faces are there? So 6 by 15 squared. 6 by 225, which is 1350. Yay. Surface area of a cube with that volume. So, volume equals s cubed, correct? Which means 216 equals s cubed, which means s equals the cubed root of 216, which you know to be 6 equals s. Now, you know the side length is 6, so it's 6 times 6 squared, which happens to be what? 216 centimeters squared. You guys know I love to do that to you, like I did on your cumulative, right? The volume and the surface area had the exact same number, but different units. All right, everybody's ready to move it along. Page 125, please, everyone. And this, let's have a moment of silence for the square root button on our calculators, because we're not going to use it again. Everybody, time's up. Just like we had to have a moment of silence for 3.14, because we were never going to use that again. What? So, simplifying radicals. We know that radicals are these things. X, root, something. Every time you see this symbol, you are dealing with a radical. You know that those radicals come in two different flavors. They are either rational or they are irrational. In a rational radical, the square root sign will disappear. I shouldn't have said square root. The radical sign will disappear. In an irrational radical, we cannot get rid of that. Your calculator gets rid of it by giving you a guess. The square root of 2, 1.414, blah. It is not the square root of 2. It is an estimate of the square root of 2. Okay? So, a radical is any expression using that symbol. Okay? An entire radical, and I'm going to highlight these two because they are different things. An entire radical is 1 times the radical. Now, when 1 is out in front of something, do we ever write it? No. This is technically what it is. How does it appear? Like that, with no number in front of it. What do we call the number in front of anything that multiplies it? A coefficient. An entire radical has no coefficient. Okay? Which is only to say it looks like it has no coefficient. Because it technically has a coefficient. What is it? 1. But we don't write it. Okay? Now, being the intelligent young people that you are, a mixed radical looks like this. A. And the A is a coefficient. What do I have to remember about coefficients? What is their mathematical task? What does a coefficient do? Multiplies. Coefficients always multiply. I. Now, is this an entire or mixed radical? It is entire. Why? Because there is no coefficient. So I'm going to highlight it blue because it is entire. Now, just like in grade 3 with Mrs. Bad Crumble, how you would never, ever in a million years dream of leaving that fraction. Why? Because it's not simplified. Just like in Mrs. Bad Crumble's class in grade 3, in Mr. Bad Crumble's class in grade 10, we don't leave anything ever that can possibly be simplified. Now let me ask you this. Which is a simpler number? 2 times 2 times 2 times 3 times 3 or 72? Okay. What is the simpler number? 2 times 36 times 10 times 2 or 1,440? Excellent. Simpler to read. In math, simpler means what? Smaller numbers. So in reality, simplify means make it look simpler, yes? In math class, simplify means smaller numbers. Because in grade 3, 1/3, they're both fractions. But we like this one because it uses the smallest numbers. So, although the square root of 72 is very easy to look at, it's very easy on the eyes, it is not the simplest numbers that it could be. Yes. Okay.
Wait, would you go?
Yes, Sue, honey? Okay. 72 gets smaller. What math process do we have that breaks 72 into smaller numbers? Factoring. So let us take 72 and see what happens when we break it down. I am going way over here because I'm going to do the easiest method that also, believe it or not, requires the most work, even though it's the easiest. 72, factor that. Go. What is your first break going to be? I am betting all of you are going to write 8 and 9, but I'm not 100% sure. Can I stop at either of those? Yes, if you can do the rest in your head. We're getting to that, though. Can I stop at either one of those? No. 8 is 2 and 4. Can I stop at either one of those? Only at 2, because 2 is what? A prime number. So I break down 4 again, 2 and 2. 9, 3 and 3, and that stops. Now that should make you aware that the square root of 72 is the same as the square root of 2 times 2 times 2 times 3 times 3, right? Which is the same as the square root of 2 cubed times 3 squared. Yes? Is everybody good to there? Yeah. Now, if this radical sign was being written technically, what little number would be right there? A 2. And that little number, the index number, tells me that I am seeking how many equal factors? 2 equal factors, yes? Looking in this list, do you see any groups of 2 equal factors? Where? You see 2 2s and you see 2 3s, correct? Everybody agree? All right. Now that means that this also equals the square root of 4 times 9 times 2, correct? 4, 9, 2. Everybody agree? What is the square root of 4? 2. So if I gave you this, square root 4, what would your answer be? 2. So the square root of 4 is what? 2. So a 2 is part of this answer. But it is not done yet, is it? Because there's still a 9 and a 2 under there. What is the square root of 9? 3. So if I gave you square root 9, what would you do? It would be 3. So I need to have a 3 out there. Because there's a group of 2. There's a group of 2. They are now in front of a radical sign. What does that make them? Coefficients. And what is a coefficient's job? Multiply. What is 3 times 2? 6. What did I leave under there? Why? 2 does not have a square root. And we are never going to be using our button again, so we leave it. That, for the rest of your math career, is the answer to square root of 72. Now, if you were listening, you heard Suhani say she could stop right there if you could do the rest in your head. Actually, you can stop one step earlier than that. Observe. Isn't 72 36 times 2? So doesn't that mean the root of 72 equals the root of 36 times 2? What is the root of 36? So what comes out here? 6. What stayed under there? 6 root 2. So notice, if you get a branch that ends in a square root, you may stop. Remember how I said knowing your perfect squares would be helpful? Here's when. Now, a great deal of you are going to be like, ooh, yuck, ooh, not quite ready for this. That's okay. We start with nice and easy ones. 99 isn't a perfect square, but it breaks down into what? 9 times 11. Is one of those a perfect square? Which one? 9. So this is technically the square root of 9 times the square root of 11. What is the square root of 9? 3 times the square root of 11. Now, do you need to write out this step? No. This is what is actually happening. Some students like to see this so they understand what is really going on. Most students are looking for the shortest cut possible, which is, 9's a perfect square, so I bring out the square root of 9, 3. 11 doesn't break down, so I end up here. Everybody good? Now, what if, for some reason, you did not recognize that 9 was a perfect square? Would you be stuck? Of course not, because you would have made this factor tree. 9 and 11, 11's a prime. 9, 3 by 3. Then you have said to yourself, I am looking for the square root, which means I'm looking for groups of 2. Is there a group of 2? So out will come the 3. That's got no group, so it stays. Everybody good? So if you recognize a perfect square that lives inside your radicand early, then you can save yourself a lot of work. But if you don't recognize that radicand, then you just finish your tree.
I know we said goodbye to our square root, but that already worked out on my calculator.
Yes, I'm actually about to get to that. Some of the newer calculators recognize that we do not want decimals. And rather than make you learn math, they do this for you. You're welcome to do that. But if you show me this with none of this, you are not showing me you understand anything about math. You are showing me you know how to push buttons. And since you are all under the age of 20, I know you can all push buttons. Because you've been raised pushing buttons. Selena. All right? So, whether or not you have a newfangled fancy calculator that does this for you, you still need to know how to do it. Because eventually there will be more under that radicand than just numbers. And your calculator cannot deal with that yet. Everybody cool? So let's have a look at 75. Do I need to break it down? Of course I do. What is the best first step? Okay. We have a 15 and a 5. Are either of them prime? 5 is prime. Is 15? What's 15? 3 and 5. Now they're prime. Is there a group of 2? What is it? So what comes out? 5. What stays under? 3. Now I would submit to you, if you knew your perfect squares, would you not have been saved yourself a step to go 25 times 3? What's the square root of 25? 5. So what comes out? 5. What stayed under there? 3. Do either one of those make any more or less mathematical sense? No. They are strictly there for time saving. So do I care which you use? No. But you have seen both. Do I care how you factor? Can you use a tree? Can you do this steppy thing that I showed you, that I was taught? 3, 25, 5, 5. Oh, there's my pair. Is that okay? Of course it is. Does not matter. Jaslyn. We're going to get to that very, very soon. Okay? Let's break down 80, shall we? I am betting that all of you are going to go 8 times 10. Am I right? No? What did you do? 40 times 2? Okay, weird. That's fine. Okay, just wait. I am also hearing 20 times 4. Okay? The point is, will it matter? No. So, 8 times 10, I'm going to stick with 2 times 4, 2 times 2, boom, boom, boom. 2 times 5, which means the square root of 80 is also the square root of 2 to the 4th power times 5, correct? Now, Jaslyn just asked this. What if there's more than 2? Is there more than 2? There's 4 2's there. How many groups of 2 can I remove? 2 groups of 2. So I can bring out 1 2, and I can bring out another 2, or 2 squared, leaving what under there? 5. Would I write 2 squared? No. 4 root 5. Now, of course, you could, if you knew your perfect squares and were good with division, could have done this all in one step, yes? Because, of course, 16 times 5 is 80. What is the square root of 16? 4. What comes out? 4. What did I leave under there? 5. Everybody good? Great. What's D? You could do 10 times 30. I wouldn't. I would do 100 times 3. Why? Because what's the square root of 100? 10. So what comes out? 10 root 3. Now, what if you did 10 times 30? Well, you'd break it down. 2 times 5, 2 times 15, 3 times 5. And you would see there's a group of 2, so out would come a 2. There's a group of 2, so out would come a 5. And there's a lonely old 3 living under there. 2 times 5, of course, because they're coefficients, gets me 10 root 3. Yeah? Yeah. 63. 9 times 7, so you bring out 3 root 7. 32. 16 times 2, so you bring out 4 root 2. 363. 3 times 121, so you bring out 11 root 3. Yeah? Yeah, sure, you betcha. Turn the page over and reverse the situation. If there's 1 2 out here and I'm seeking square roots, how many 2's had to live under there? 2 times 2. What is 5 times 2 times 2? Root 20. Everybody good? That's the answer. What's this one? Root of 29 times 7 squared. Can't really do that in your head. 29 times 49. What is it? 1,421. Let's use numbers, shall we? That's okay. What about this one? This one's weird.
What's that number besides 7? The second one? On B?
Squared. Because there's 1 7 out there, so there had to be 2 under. What's this one? Why is it 12, Manraj? Oh, who said 12? Oh, why is it 12, Najim? Because 4 is a perfect square. Right? Don't get trapped in steps. Use your brains. That is the square root of 144, which would equal 12, because you wouldn't leave it that way, would you? 12 has less numbers. And now, D is always a kerfuffle.
What's with C? What?
Well, isn't the square root of 4 2?
Yeah.
So isn't that 6 times 2? Which is 12. But it's also the root of 4 times 36. Because that's 6 squared, right? 4 times 36 is the root of 144, which is 12.
Quick question. Mark, Jeremy's finished trig.
Uh-huh.
Would you be able to email me the test
Yep.
when you have a second?
Uh-huh.
Appreciate it.
What's going on in D? D is a concern, a particular concern of mine, because once again, it proves how little about the nature of numbers you guys actually know. It's a big deal.
Isn't it like 5 is negative, so isn't it -5 times 5?
Okay, that's what Selena says. What are you saying, Suhani? Okay, what do you say, Arsh? Same as Suhani? Yes. This is not -5. This is negative 5 root 12. Okay? That's what this means. which means what should be under there? 12 times 5 squared, which is 25, right? What's 12 times 25? Root 300 with a negative out in front. Now, if you do what Selena said, you're going to get the same value, aren't you? You're going to get root 300 under there. But it will not be a negative, which it needs to be. Does everyone understand? Which leads us to a corollary of this rule, which is this. Square root of 300, we know to be, could be 5 root 12, right? We would simplify that 12 more, but we're cool here, yeah? Right? Is there a square root of negative 300? No. Why not? Ashni. Right. A square root needs two equal factors, correct? Anytime you multiply two equal things together, you get what? A positive number. So this can't exist, but this can. Everybody good? Now, before we go any further, I will tell you that this does exist. This is called an imaginary number. Just when you think you've got a handle on the real numbers, you're going to be hit with a whole set of numbers called imaginary numbers. You don't need to worry about them till second or third year math. Second or third year physics. Okay? For your intents and purposes at university, your intents and purposes, this doesn't exist. Okay? So, don't worry about it. However, that does exist. What? We'll get to it. Okay? All right. Look at number 3. Please notice that I have yet to show you a cube root. But I have shown you how to simplify radicals, yes? So what do you think differs now? McKenna. Well done. Absolutely correct. Without me even teaching you. Do you think anything else changes? Yeah, you got to bring out 3. 3 whats? What are those numbers called? Ask Jasleen, she just said it. 3 factors. So I must still need factors, yes? So do my methods change? No, I still need factors from which I am going to seek groups of 3. So what does 54 break down into? I am betting all of you are going to go 9 times 6. That's cool. Can you stop at either of those? No. You're going to go 3, 3, and 3, 2. And oh, what do you see? A group of 3. So what comes out? 3, cube root. What stays under there? 2. Now, could you have done it shorter in one less step if you knew your perfect cubes? Yes, of course, because 54 is 27 times 2. What is the cubed root of 27? 3. So out will come 3, leaving there 2. So once again, if you know your perfect cubes, you can save time. But if you don't know your perfect cubes, you're not at any kind of disadvantage, mathematically speaking. Okay? What about B? You got to break it down, yeah? Most of you are probably going to go 12 times 12. Can I stop? No. 3 and 4. 3 and 4. 3s are cool. What are 4s? 2, 2, 2, 2. as you can see, it sometimes gets rather busy, doesn't it? The bigger the factor tree, the harder it is to find all those factors. So I like, sometimes, when I am dealing with these, to rewrite my radical using exponents. 2 to the 4th times 3 squared. And now it's super easy, because I need groups of 3, correct? Is there a group of 3 here? Yes, there is, as a matter of fact, because there are 4 of them. So I can take out what? 3 of those 2's, which is one whole set, which means 2 comes out to the front. I needed 3, I had 4. So what did I leave under there? 1 single 2. Can I get out any groups of 3's? No, so I have to leave the 9 under there. So this becomes 2 cube root 18. Yeah? Yeah. Ganika.
Wouldn't we simplify that to 4, 18?
Why?
No. Sorry, 8. Like, shouldn't that be more simplified?
How? 18 breaks down into 2 times 3 times 3. Are there any groups of 3 there?
No, I meant like 8 and then 18.
What 8? Where is there an 8?
Never mind. I messed up.
Okay. What is different in C? There's an index of 4, which means what size of factor group am I seeking? 4. Does anything else change? No. So I have done this so many times that I can do this with a 4th root, because I know some 4th roots. But most of you probably do not. So you're going to break down that 128, and it's going to be hideous, because it is a factor of 2, which means there's going to be a crap ton of 2's. 128, 2 times 64, damn. 2 times 32, damn. 2 times 16, damn. 2 times 8, damn. 2 times 4, damn. 2 times 2. Whoo, doggy. How many 2's? 2, 3, or 1, 2, 3, 4, 5, 6, 7. 4th root of 2 to the 7th. How many 4's fit into 7? 1. So I can get out 1, 2. What did I leave under there? 2 to the 3. That takes 2 numbers to write. We want it in as few numbers as possible, so it is 2, 4th root 8. Is everybody good? Yeah? Great. You guys do D, E, and F. That's fine. Then you're going to get 8 and 8. Then you're going to have to keep breaking down the 8's. No need to be so aggressive, Jasleen. Holy. Don't worry, McKenna and Prab. I'm moving you guys on Monday, so you don't have to be pushed around by Jasleen anymore. Please notice, with practice, with practice, I can do it in one step. Does that make me any better than you? Of course not. It's just practice. Is everybody good? Do people want to see these broken down further? The way most of you probably did them. Or are you happy with seeing it this way? Everyone is good? Of course, 81 must be 3 because it's 9 times 9, which is 3 times 3 times 3 times 3. There's my group of 4. Everyone's cool? All right. Now, hopefully you are noticing something. What numbers are consistently showing up out here? 2s and 3s, right? Because how often do I have a power of 2 or 3 under the radical sign? Very often, yes? So what allows me to see some of this better? I've memorized a few of the powers of 2 as well, because it comes in very handy. 2, 4, 8, 16, 32, 64, 128, 256, and that's about where I have stopped memorizing. 2 to the 1, 2 to the 2, 3, 4, 5, 6, 7, 2 to the 8th. I'm up to there. I'm actually pretty good up to 2 to the 10th, which is 512 and 1024. And I'm pretty tapped out there. I mean, seeing it written out, I could go on, right? 2 to the 11th is 2,048. 2 to the 12th is 4,096. 2 to the 13th is 8,100. And that's where I'm tapped out in my head. Right? Yeah. 92. Okay? And 3, 9, 27, 81, 243, and that's about where I tap out in 3s. But it's good to know them. That's what allows me to do these faster, because I have all of these sitting in my head too, ready to pick up. Everybody good? Not necessary, but helpful. Now, when you turn the page over, you get to what Brendan asked about earlier. My calculator will do this for me. It will simplify radicals until this point. Right? Now, what little number should be right here? 2, which means I'm seeking groups of what? 2. Now, in reality, this is the square root of 32, which I know how to work, times the square root of x squared, yes? What is the square root of 32? Well, we know it is 16 times 2, so it is 4 root 2, correct? And what is the square root of x? It's x times x, right? That's a group of 2, so out will come an x. Agreed? Now, that is not under the radical sign, is it? It's a coefficient, right? So the answer must be 4x root 2. That's what's really happening. McKenna?
If it's the square root of x squared, then the square root is x.
Yeah. That's why I brought an x out and I left nothing underneath. Okay? That's what's really happening, yes? But as you well know, what is really happening differs slightly from the way that we actually do the math, yes? So what we actually do here is we continue the same thinking that we had before. We know that 32 is 16 times 2, correct? And we know that x squared is x times x, correct? And we know that that's 4 times 4 times 2 times x times x. And we know that there's a group of 2, 4. There's a group of 2, x, and I left a 2 under there. Okay? Now, I want to show you something that allows you to make yet another shortcut if you understand what is going on. What do you see right there? 2. What do you see right there? 2. So I can go ahead and say that since I got 2 under there, I get to bring that 2 out. Right? 2 divided by 2 is x to the, what exponent should be here? 1 that we don't write. Was there any remainder? 2 divided by 2 is 1 with no remainder, correct? So there is no x remaining under here. That is now 3 ways to do these questions. Who chooses which method you are going to use? You do. Aight? So, this one right here, I'm going to work with you. Then I'm going to give you guys one to do. I'm going to work all 3 methods. Method 1, that is the cubed root of 48 times the cube root of x to the 7th times the cube root of y to the 5th. Cube root of 48 is, of course, 8 times 6. What's the cube root of 8? 2. So out comes a 2, and I left a 6 under there. Cubed root of x to the 7th, how many groups of 3 come out of there? 2 groups of 3. So I got x, and what did I leave under there? 1 single x, because I could take out 6 of them, right?
Wait.
Okay. If I'm looking for groups of 3, how many groups of 3 can I remove from 7? I can remove 1 group of 3 and then a second group of 3. So I have 2 x's that came out. Did I remove all 7 x's? No, I had to leave 1 x under there. How many groups of 3 can I get out of 5? 1. And how many is the remainder? 2. So now I have 2 x and y outside of the radical sign. So I have 2x squared y, and under the radical sign, what did I leave? 6x y squared. Is everybody good? That's method 1. That's the longest method, requires the most work, but is very easy to see and understand.
I simplified the 6 to a 3. Is that okay?
No. Because you left a 2 and a 3 under there.
Okay.
All right. Everybody good? Now, could you do this method right away? Yes. You know that 48 is 8 times 6, so you know you're bringing out a 2. You can see that I need groups of 3, so 7 is being divided by 3, which is what? What's 7 divided by 3? 2 with 1 remainder, right? So I'm bringing out 2 x's. What is 5 divided by 3? 1 y, and I left a remainder of x to the 1, y to the 2. 6xy squared. The shortcut is I can just divide this in, leaving the remainders underneath and bringing out the answer. If that shortcut is making you go, should you waste brain power on that shortcut? No! Just do the math. Let's pretend that you don't even understand this step. Let's pretend, because all of you understand this step. Could you do this way? Root of 2 times 2 times 2 times 2 times 3 times x 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 times y times y times y times y times y. Cube root. What am I looking for? Groups of 3. There is a group of 3, so out comes a 2. There is a group of 3, so out comes an x. There is another group of 3, so out comes another x. There is a third group of 3, so out comes a y. And what did I leave under there? 2 times 3 times x times y times y. And then you would write it out normally. 2x squared, because we want it as simple as possible. Y, cube root, 2 times 3 is 6, x, y squared. If you know what is happening, you can always find the answer, regardless of what crazy-ass method your math teacher shows you. Now, in a class where I'm not as trusting of the number sense as I am of you people, I open with this. I want you to attempt to finish 127 and 128. Go. Attempt it. I know the bell is rung. That's your homework. Attempt 127 and 128. Go away. Bye, guys.
Bye.